Hello, this is question 16 on your November 2021 paper from Edexcel, the AES paper. You have a curve with this equation, is a cubic where A and B are constants. So I have an A here and a B here. Point 210 lies on C and the gradient of the curve at 210 is minus 3. We have to find A, and the value is minus 2, and find B. So we are going to use this information to form a couple of equations that we are going to solve. So if the point lies on C, it means that must satisfy the equation. So f of minus 2 must be 10. So I'm going to substitute that. F of 2 is going to be 2 cubed times A is 8A. 2 squared is 4 times 15 is 60. Minus 39 times 2 is 78, plus B must be 10. I can rearrange and organize a bit my equation, and I have that 8A plus B is 28. I have one equation with two unknowns, A and B, and I'm going to form another equation with this condition. The gradient is going to be given by the derivative, so f prime. And it says the gradient at 2, so when x is 2, is going to be minus 3. So I'm going to find the function derivative and substitute the x by 2. So the function derivative is going to be 3ax squared, 3ax squared, 2 times 15, 30x, so plus 30x. This one is minus 39. And then I'm going to substitute the x by 2. So I have 2 squared is 4 times 3, 12. So 12a. So f prime of 2 is going to be 12a. And then 30 times 2 is 60. So plus 60 minus 39 is going to be minus 3, which means I just have one unknown, which is the a, that a is minus 24 divided by 12, which is minus 2. Yeah, so this is the first one. And now I'm going to find b, substituting this minus 2 here. So I'm going to go with this minus 2 here, and I'm going to find b. And b is 44. Yeah, so I found a and b. Then, hence, show that C has no stationary points. You know the stationary points, the way of finding it is making the derivative equal to 0. We have the derivative here, so we are going to make that equal to 0 and see if that's possible. So we have that 3, and now we know the values of A and B. So 3A is going to be minus 6. So I have minus 6x squared plus 30x minus 39. I have to solve this equation. I can divide by minus 3, for example, to have something nicer. So 2x squared minus 10x plus 13. And if I have to prove that has no real solutions, what I can do is to use the discriminant, remember? So this is going to be b squared. B is minus 10, so minus 10 squared is 100, minus 4 times a, which is 2, and times 13. This is minus 4, and minus 4 is smaller than 0, which means I don't have real solutions. Yeah, so I don't have stationary points. C, I have to write the function as a factor that is x minus 4, and then another function which is a quadratic. To do that, that means this is a factor, so I'm going to divide my expression by x minus 4. So I'm going to divide for C, x minus 4, and I have my quadratic, my cubic here, but I know the values of A and B. So A was minus 2, so minus 2x cubed, minus 2x cubed, plus 15x squared, minus 39x, and then was plus b, and b was 44. I'm going to divide this, and I'm sure I'm going to get remainder 0. If I don't, I did something wrong. So minus 2x cubed divided by x is minus 2x squared. I multiply this by this, remember, so minus 2x cubed. Then I multiply this by this. I have positive 8x squared. And I subtract. These two are gone, and then I have 7x squared. I divide again, so 7x squared divided by x is plus 7x. I multiplied this by this and by minus 4, so I have 7x squared minus 28x, and I subtract. These two are gone, and minus 39 minus minus 28 is minus 11, minus 11x. I divide again, so this one is minus 11. I multiply, and I have minus 11x plus 44. And when I subtract, these are gone, and these are gone. That's my remainder, which means the fx is going to be x minus 4 times this expression that I have here. So the quotient is minus 2x squared plus 7x minus 11. And that's the expression that they were asking me for. Yeah, this quadratic, the qx. Hence, deduce the coordinates of the points of intersection of the curve with equation f 0.2x. So you can see here. So if you try to solve this quadratic equation, you will see that it has no real solutions. So which means my cubic only has one real solution. So my cubic, if I kind of roughly represent it, x cubed, the coefficient of x cubed is negative, so it's going to do something like this. Y-intercept is minus 11 times minus 4, so 44. Positive 44, and the only cut with the axis is the 4, positive 4. So my cubic will be doing roughly something like this, maybe. It's just to give you an idea. So if I'm trying to find f of 0.2x, remember when I'm doing f of, and I multiply the number, the x by something, I'm scaling this horizontally, and the scale factor is going to be the reverse. So the scale factor is going to be 1 over 0.2, which is 5, which means I'm horizontally multiplying my function by 4. This point is not going to change because the x is 0. So even if I multiply by 0.2, it's going to stay where it is by the 4, but the 4 is going to go to the 5 times 4 because I'm multiplying everything by 5. Yeah, so my new point of intersection is going to be the 20. And that's what they're asking me. So I have to deduce the coordinates of the points of intersection of the curve with the coordinate axis. So one, the y-intercept is 0, 44, and the other is 20, 0. Those are the points of intersection. Yeah, and that's it with this exam question.